Have you ever noticed how sound travels through the air or how light travels through space? These are examples of waves, but not all waves are the same. Welcome to Science Bites. Today, we'll explore the fascinating world of mechanical and electromagnetic waves and how they shape the world around us. So what are mechanical waves? Mechanical waves need a medium like air, water, or a solid to travel through. Think of ocean waves moving through water or sound waves traveling through the air. These waves transfer energy from one point to another by causing particles in the medium to vibrate. Examples include sound waves, seismic waves, and even the waves on the surface of water. There are two types of mechanical waves, transverse waves and longitudinal waves. In transverse waves, particles move perpendicular to the direction of the wave, like ripples on water. In longitudinal waves, particles move parallel to the wave's direction, like sound waves or a slinky being compressed and stretched. Unlike mechanical waves, electromagnetic waves don't need a medium to travel. They can move through the vacuum of space. These waves are caused by the oscillation of electric and magnetic fields. Examples include light, radio waves, microwaves, X-rays, and even Wi-Fi signals. Electromagnetic waves travel at the speed of light, which is about 300,000 kilometers per second. Here's an important difference. Mechanical waves, like sound, can't travel through space because there's no medium, but light, an electromagnetic wave, can. That's why we can see the sun's light but can't hear sounds from space. The formula that links wave speed, wavelength, and frequency is V equals sign φ, where V is the wave speed, F is the frequency, and lambda is the wavelength. Whether it's sound waves, ocean waves, or light waves, all waves carry energy. Understanding the difference between mechanical and electromagnetic waves helps us explain everything from hearing music to receiving signals from distant stars. Next time on, we'll dive into how light waves bend and reflect as they pass through different materials. Stay tuned for more bite-sized science. Like and subscribe to for more bite-sized science that makes the universe easier to understand, one concept at a time.